Hi, so we're doing WebWork 6, question 4 as a practice problem for Norton equivalent current. So I'm just gonna do part A for this question because part B is more or less the same thing. So yeah, here part A asks for the Norton equivalent between terminals A and B with terminal C removed. So let's just remove terminal C first, and let's pretend that's perfectly removed. And the next thing we do is we have to short circuit between A and B. And since we're assuming A is on top, the Norton equivalent current is flowing from A to B. Okay, and then all we need to do is doing a simple mesh analysis. So as we can see in this circuit, we have 3 meshes. Let's call them I1. Why am I writing a different thing? I1, I2, and I3. Okay, so notice that there's actually a current source between I1 and I2. In this case, we have to do a super mesh around the current source because we don't really know what the voltage around the current source would be, right? Okay, so let's do super mesh. And let's just start from here. Let's say negative 18 plus R1 would be 12. 12 times I2 minus I3 plus 18 I1 plus 8 equals to 0. And mesh 3 gives us 12 I2 minus I3 equals to 0. And then we have an additional information from our current source, which states I1 minus I2 equals to IS. In this question is given as negative 4. Okay, so we have 3 unknowns and 3 equations. The 3 unknowns are I1, I2, and I3. And we can now solve for the whole circuit. And just notice that IN is actually equal to I3 in this case. So that's the Norton equivalent for my part A. Okay, this question also asks for the resistance, equivalent resistance for the circuit. So in this case, it's relatively simpler just because there are no dependent sources in the whole circuit. So I can just kill the voltage sources and short circuit the current sources. Okay, so I'm just gonna sort of replicate my circuit down here. This is R1. This is R2. And I have short circuited my IS, which is supposed to be here. Okay, so this just looks like a 2 resistors connected in parallel here, right? So if it's not completely obvious, just think of it like this. This is the exact same thing, right? You're thinking about like just dragging this line to like here, right? And then dragging this line to like, okay, let me just rewrite this. Okay, I'm dragging the blue part to here and dragging the pink part to here. So yeah, to calculate the equivalent resistance, we just calculate the equivalent resistance of these 2 resistors connected in parallel, which would be R equals to 1 over 12 plus 1 over 18 to the power of negative 1. Hopefully this is clear enough.